Hello students. Today, in this video lesson, we are going to talk about the acoustic fundamentals of digital audio. To help you to understand this topic better, I'm going to introduce you an audio analysis software which is called PROUD. And the last part of the lesson, I'm also going to introduce you another software which is a music analysis software too, and it's called Riff Station. What is sound? Sound is a type of energy made by vibrations. When any object vibrates, it causes movement in the air particles. These particles bump into the particles close to them, which makes them vibrate too, causing them to bump into more air particles. This movement, called sound waves, keeps going until they run out of energy. If your ear is within range of the vibrations, you hear the sound, and this range is between 20 Hz and 20,000 Hz, and 20,000 Hz equal with 20 kilohertz. If you hit a tuning fork, the two parts of the fork is going to vibrate. And when you touch it, you actually stop the vibration. Sound is a series of longitudinal or compression waves that move through air or other materials. The 5 defining aspects of the sound is: number 1, pitch or frequency; number 2, dynamics or amplitude; number 3, timbre or tone color; number 4, articulation or envelope; and number 5 is the duration. Now let's take a look closer. The characteristics of waves. All periodic waveforms have these common characteristics, like wavelength, amplitude, velocity or speed, and frequency. The highest top or crest of the wave until the next crest of the wave, we count the wavelength. Now if we go back, that the pitch or frequency depends on the length of the wave. So if you see, the higher note is, the shorter the wavelength. The lower note is, the longer the wavelength. Now the next is the amplitude. Amplitude depends on the dynamics or the volume of the sound. We have soft volume and we have loud volume of the sound. In case of soft volume, the amplitude of the wave, of the sound wave, is very short. And the case of loud volume or higher dynamics of the music or of the sound, the amplitude of the sound wave is taller. So if I have a soft sound or if I have a loud sound, there is no difference between the frequency or the pitch of the same sound, but there is difference of the size of the sound wave. And what gives the size of the sound wave is the amplitude. When a waveform consists of only one frequency, that waveform is called a sine wave. The sine wave or sinusoid is the most fundamental waveform. So what are we talking about now? We are talking about timbre and tone color. To distinguish a different instrument, it requires much more thing than a simple sine wave. A simple sine wave can be produced by a machine, or actually the tuning fork that I just showed before is also one of the purest sound wave, which is the closest to the sine wave. The complex periodic waveform is the result of combining the amplitudes of two or more sine waves. The lowest frequency component of such a series is called the fundamental or first harmonics. The other higher frequency components are called overtones or harmonics. Each natural frequency that an object or instrument produces has its own characteristic vibrational mode. This is the tone color or timbre, which causes difference between the instruments, human voices, and etc. On the picture, the red line is the fundamental or the first harmonics of a note. Let's say this is the unit. Okay, this is the length. The second harmonics vibrates twice fast as the first harmonics. Do you see with the blue? And the third harmonic vibrates 3 times faster than the fundamental. Do you see it's in green? And the multiplication of these 3 sine waves will make the complex periodic waveform of that instrument or of that sound. Device which transforms energy to a different form, and this different form is an electrical energy. We have 2 sound transducers. One is a microphone, let's say something like this, and the other one is a speaker, something like. And the microphone transforms sound wave to electronic energy or signal. The speaker transforms electrical energy to sound waves. Room acoustics or building acoustics or architectural acoustics. It's the same term for about how sound waves interact in a room or in a closed place or in even open place. Because each room and all the objects in it will react differently to different frequencies of sound. And every speaker will sound different in different rooms. But why? If you look around in your room, or if you look around in my room or my surroundings, I have walls around me, I have ceiling, I have the floor, I have different materials which are probably covering the different surfaces, and these are all affecting, these surfaces are all affecting the sound's behavior, the sound waves behavior. The sound is not losing its energy. The sound wave is always moving on. A reflective surface. I have the surface. I have the sound wave, which is actually coming and bouncing on the surface and then bouncing off from the surface. So mostly your sound waves are bouncing off from the surface. The opposite of this is the acoustically absorbing surface. It could be a curtain or a carpet on the floor or even carpet on the wall. It means that mostly the sound waves are absorbed. Now, there are acoustical panels, if you look around on the internet, which are helping to improve the acoustic of a place or acoustic of a room. And these acoustical surfaces, they are diffusing surfaces. Their aim is to when the sound wave is coming and bouncing on the surface, it's actually the good acoustical surface is diffusing or scattering the sound wave to all directions. In this picture, you see a speaker and you see three arrows. One is red, one is green, and the last one is blue. Now, the sound normally is not reaching your ear once if you are in a close place. Because why? Because the sound propagates as a circle. So it propagates in any direction. So it goes here, 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 here. When it meets with any surface, it bumps on it and it reflects or it absorbs a part of it. Well, the direct sound is the red line, is the red arrow, comes from the speaker and goes directly to the guy ear without any interrupting. The green is the early reflection, which bumps once and then reaches the guy ear. Now, the best if these two is coming around the same time. Now, the reverberation, we are talking about good and bad reverberation. The bad reverberation, if there are too much reflective surfaces in the room and the sound wave is just bouncing back and forth, and there's too much bouncing and too much time spent between the direct sound, the reflection, and the reverberation. Now, if the reverberation sound doesn't bump too much, like just let's say 3 times or something like that, then it has then the room has a good reverberation. The reverberation is a re-echoed sound caused by multiple reflection of the sound within a closed space. I would suggest you to go through on this question, and if you are able to answer it, then your job is done, then you understand this topic, and then it's well done for you. In computer applications in music, there are several softwares which are using the complex periodic waveform. It's good to know that what is this sound wave, what consists of, why is it like that, what the components of the sound, what is the 5 aspects of the sound. Now we are going to check all of this with the help of this audio analysis program, which is called PRAT. I open the program, I press new, and I record a mono sound. Now you can put the sound, which is tuning fork first. I save it. And the last one, we are going to generate a sound, create sound as pure tone. Remember, I said the pure tone is the only tone which consists only the sine wave. Let's say it's gonna be the same now, 440 Hertz. We were working on only the 440 Hertz with the different sounds. Let's make a little longer, let's say for 5 seconds. Apply, and I say okay. So we have 5 sounds, and let's see how they look. I said that the tuning fork is the closest to the sine wave. Let's go, see? Get almost a beautiful sine wave. 441 Hertz. This is the sound intensity, which is 73 decibel. We measure the sound intensity with the decibel scale, and 73 is a kind of pleasant sound. Let's see the 4 months. You see that the fundamental is very strong, right? But there are some overtones. The piano sound, look at it, take off the 4 months, look at this. I'm going to zoom on this part, I would say, okay. So you can say that, you can see that the attack here, the attack part, the decay, the sustain is not too long, and the release is quite long. Yes, in this, in the piano sound, you see it's 440 Hertz, so the same pitch than the tuning fork was. You can, let's see the 4 months, which are the overtones. Here is the fundamental, and here are the overtones. The overtones in terms of intervals are, if I have the fundamental of Do, I have the octave, the perfect fifth, the fourth, the major third, the minor third, the minor third, the major second, the major second, and the major second. So if I hear, yeah, this is the overtone series. Or my singing, wow, do you see the intensity? The sound intensity? You see, I had some vibrato on my singing. Let's listen it back. Right? Let's see the complex periodic waveform of singing, especially the A vowel, because any vowel has different complex periodic waveform. That's why you can actually distinguish between that this is an A, this is an E, this is an O, this is an U, and so on. Let's see the sound of the viola. Very beautiful. Yes, 441 Hertz. Let's see the complex periodic waveform of the viola. It looks like this. Just a little bit focus on more. Beautiful. So it's like that. And let's see the machine generated sine wave. Look at it. Absolutely, perfectly straight, beautiful sine wave. No interruption with overtones. Nothing. See? It's just one massive sine wave. The 440 Hertz is the same. Yeah, sound intensity is the same around, right? So this is the sine wave. Riff station, this one. Now you can upload a file, open audio file or open CD track. I like this song. So you see audio uploading. You can see the sound wave here. You can see the chords. Although originally Riff Station is for guitarist, because if you see the chord viewer shows a guitar fretboard. But if you play on the piano and if you can recognize like these chords, you can easily adapt your piano playing. Jam Master, let's start the music. You can see in white what is the next. So if you're familiar with G minor, B flat major, F minor, you can change the BPM, you can make it slower. If you want to practice slower music and then gradually make it faster, if you want it faster. You can also change the pitch. You can see that automatically changes the chords. Yeah, or go back to the normal. So if you want to isolate different parts of the music, you can isolate that. You just listen to the accompaniment, or you just listen to the soloist and another part. Now the chord viewer that I've already talked about, it also shows the same thing. You can change the key, you can change the tempo, you can change the chord type for power to open. These are for guitarists. If you know something about guitar, it's really great for you to play on it. Chord finder, you can choose that which chord, and it shows that how to play this chord. Now the riff builder, just shortly to introduce you, you can put together your own riff band. yeah, your own riff bank. Like that. Let's say this is the A riff. Let's do the B riff. This and 4. It's just randomly. And you can make your own song builder. By the way, what is riff? In terms of the music itself, the series of notes, chord pattern, or musical phrase that is repeated is called a riff. Often a riff is used as an introduction to a song, such as a guitar riff. It is a noun and a verb. In the case of this song, the riff, you can hear it at the very beginning of the music, before the singer starts to sing. So this is a riff. This is the riff of this song. Okay, so you can build up your own riff. Let's say this is an A, this is a B, this is an A. Thank you very much for listening to today's video lesson. I hope that you have learned a lot and see you next time. Bye bye.